Okay, so CIN object. So we've talked about the cout, which displays data to screen. So today we talk about CIN, and this will be in examples 01 module. And we had skipped it last week, but here we are this week, and we want to show it. So let me see here. Before we go, let's just show how to use the CIN object. So it's also part of the IOStream header. So the CIN object, like the cout, C++ compiler creators had to write code for us, right? So if we use IOStream, and then we can say using cout, we're going to use the cout object, and we are also going to use the CIN object. So we can create a variable of integer type. We name it num. And the fact that I stated up here using stud.cout, then in here I can simply say cout. And then I say enter a number. So the user will see enter a number when I run this program. And then I want to prompt them for a number. So then I say CIN num. So text to display to screen, right? To help user understand what we want. We want them to enter a number and capture a number from the keyboard. And that's what this statement does. Oops. And then we can say, we can echo the number back to them. You entered some number. Okay, so let's walk through this. So first, since we know we are going to output to screen and capture data from keyboard, we have to include IOStream. Every time we use cout or CIN, we have to include this library IOStream. I don't want to be typing stud.cout in main, so I say, okay, I'm going to be using the stud.cout object, and I am going to be using the stud.cin object. I create a variable of integer type. I name it num. I display to screen, enter a number. I prompt the user for a number. And line 23, I display you entered, and whatever value the user enters, I display that to screen. So this is example 01, 03. So I go to CMake, go to SRC examples 01, input, and I go ahead and run my program. Enter a number, so I can enter the number 50, and then it echoes that back to me. It says you entered a 50, right? So the way I try to explain to students the less than and greater than symbols. So from our program, we want this sequence of characters to go to the screen. So that's why we're like, cout, you know what to do to display the screen. So that's why we're sending it into the cout object. So notice that these arrows are pointing to the cout object. And the cout object has code that can display them to screen. On the other hand, CIN, we are bringing data from the outside into CIN, and CIN knows how to assign them to variables. So that's why they are pointing to the variables. So that's the simplest explanation I can give for the symbols. Right, so 100% of the time you have to use cout with less than signs, and 100% of the time you have to use CIN with greater than signs. But the way I try to help students remember is by just telling them, well, you want the sequence of characters on line 20 to go to C out and into the display, and then they're coming out from the keyboard into CIN, and CIN assigns the values to the num variable. So, any questions on the CIN object or on this program? The math library? Like if you wanted to use the square root, I think, but we won't use that for a while, at least for a couple of weeks. Yeah. Yeah. No, you just do num1 times num2, right? Yes. Yeah, no, yeah. So we're trying to keep it as simple as we can right now, because right now it's more important for students to understand like the basics and how to work with the different types of files we use. So okay, so let me run the program again, right? So run in terminal. So it's prompting us enter a number, you see. So it got this sequence of characters, it stuffed them into the cout object. Cout object knows how to send them to screen. And now it's on statement 21 where it's waiting for us to type in a number. So as soon as I type in a number, CIN is going to have that number and it's going to assign it to num. And then we can run statement 23, which says you entered some number, right? So you entered 100. So that's how this program is read, and that's how it works, right? So statement by statement, I went through it, and that's what happens. Yeah, so I know Python makes it a lot easier, right? But once you understand that, well, I mean, it's not me, like the professor, telling you, like, you have to do this. It's C++. Like, C++ states the rules. Like, you want to see out to screen, CIN from keyboard, you have to use IOStream. And then we want to make our code readable, so then we just say using .cout, using .cin, and then we can get away with just saying cout here. So those are C++ rules, right? That's not me telling you you have to do that. It's C++ telling me to tell you. Okay, so any other questions here? Yeah, and if it, again, so I've said it before, if this seems too elementary to you, just be patient, right? So, I mean, this is like a second semester programming course, and C++ is complicated. So I'm making sure that I go at a decent pace, and I want to make sure that everyone understands how a simple program works. Once you know that, then we can move on to programs that do a little bit more than what we're doing now. Yeah, so if we use .cout, when that means everything in the standard library is available to our program. And it might seem trivial and it might be easy. Well, I mean, if I just use namespace std, meaning instead of using this, I just say using namespace tab. Well, that's not what I wanted to do. This its own thing. Using namespace stud, and then okay, what happened here? Let me just go back. Namespace So when you do this, it also works. The problem is it's easy, which is, I guess we can consider it a pro for beginners, but it's like I've said before, once you learn one way, then you're not going to change. And this way right here is not recommended for in the industry. So like if you want to work in a C++ shop, then they frown at this stuff, because this makes the whole standard library available to our program. So I know right now it's kind of trivial because we only have 4 lines of code, but if we had 1,000 lines of code, then which objects from the standard library am I using? So, and then what will also happen is this will make our executable larger, and we don't want that. And then another issue that we'll have is we'll have name clashes with other cout objects from other library vendors. So we want to be explicit, so for our own good, because in 3 months we might not remember what objects we're using from the standard library. But if we do this, then when we come back 3 months from now, I can just read that at the top and I'm like, okay, I'm using COut, CIN, math, and other libraries from the standard library, which makes it easy for me or another programmer to understand what our program's using as far as a standard library. So, okay, I know the book uses namespace std, but std, right? But I don't like to use that, and if I teach you that way, you're never going to change until they pick on you when you find a C++ job, right? And then you'll probably be mad at me. So, okay, so next topic. So we have that's all I'll cover as far as CIN, right? We talked about integers, we talked about characters, we talked about decimals or doubles, and then we talked about bools, right? We also have a string, which is a special type of data type in C++. It's not like the integer and the double and the char and the bool. Those you can just use. See, you can just use them. Like, you don't need any special configuration to use an integer. They're part of the C++ core language. The string is not part of the core language. The string is part of the C++ standard library. And if cout is also part of the standard library and it needs an include, then we can deduce that we need some kind of include to use string. So if I come here, I do need some kind of include, and, well, believe it or not, is string. So I can say include string, and then I can say using string. Once I do that, then the compiler will know that if I use string to create a variable, then it's available for me to use. We can create a variable here, string name John Doe, and then if you were introduced to objects or classes in Python, then you will understand that when I tell you that, well, string is a class or it's an object, then it has some functionality that we can use, you see? Like, we can compare, we can copy, we can clear the string, we can get the size of the string, the length of the string. And notice if I create integer, see, an integer, and if I put num dot, doesn't have any functionality, so it's a simple data type, and the string is an object, meaning it stores data. What data does it store? John Doe. And we can query the string. We can ask it questions, like we can say, hey, what's the max size that I can store in you? And I can also ask it to do things. I can say, hey, clear your shelf. I can get the size of it. And I can display the size of it. So if I say include IOStream, then I can say cout size is, close the double quote, and it'll display the size for me. So it's a special type of data type. And one other thing that I want to make sure I show you is how it's stored in memory. Let me see if I can write with my I think I can write. Let me go here. So, and let me bring OneNote to this screen. So let me add a page here. And okay, so if we have, I think I can type here. Let me make this big, like 18. If I have int num equals 5, and if I have string name equals, assuming that I have the correct configuration to use string, right? John Doe, how do these variables look in memory? And where are they stored in memory? So stack, you do have to know this, okay? Because you'll see it probably in next week's quiz. Int is stored here. Again, we know in 4 bytes of RAM, right? So that could be like some large number and 4. And then this would be some large number starting at 8. But how does it store it in memory is the question. So when we use a string, C++ manages the memory for us. When we use int, C++ manages the memory for us. There's one difference in how these are stored in memory. I should have put John. Let me just put John so that I don't have to use. Yeah. Okay. So this one gives us random memory. So say that the operating system's like, you can use that memory starting at, I don't know, this was like memory, say 100 something, right? X 100, some large number 100. So then J would be here. Okay, can you hear me? Okay, sorry, I don't know what happened. I had to disconnect and connect again. Okay, so we have int num equals 5, so it's stored on the stack at address y4. Y could be some large number. String name equals John. We know that somehow it has to be stored in y8, but the letters are stored on the heap, and I'll explain how that happens. So we have J So O, H, N. This would be, that would probably be a good idea, right? So let me see. Okay, so num equals 5, so num is stored here at y4. We know the way of explain stack memory, that it's going to be stored here maybe, but since the string is a special type of data object, the letters are stored on the heap. And remember, the heap is random, so say it picked this address x100, so then this would be address 101, address 102, address 103. And of course, the computer wouldn't store JOHN, it would store the decimal equivalency of them, or their ASCII values, right? So if you do a Google search ASCII table, then it'll show you the value of capital J, and then that value in 8-bit binary would be stored in 100. But we're not interested in that, right? So JOHN, but how does it reference this over here? So then what would be stored here on the stack would be X 100, meaning the first value for this string is at address X100. And then the string has code in there to help the compiler know that it has JOHN and that it'll only be using values up to address 103. So this is the biggest difference between the integer, double, char, and bool. String is a variable, but it's a special kind of variable. And C++ manages the memory for both of them. So what kind of memory is the heap? It's known as dynamic memory. So when we create string name equals John, behind the scenes, C++ creates dynamic memory for the string, and it knows how to store the values on the heap. Any questions here? Let me see. It's first in, first out memory. It's static memory, local memory, and the heap is random memory, dynamic memory. There's code. Remember, string is a class, meaning programmers had to write code to create dynamic memory. Which programmers? The compiler programmers. So not the compiler, the C++ standard library programmers. They wrote code that knows that if we say string name equals John, then they write code to create dynamic memory, and they initialize it to JOHN. So then they allocate at least 4 slots. So we'll get into that later on in the semester, but for now, I think that should be enough. Like, somebody had to write code to manage memory on the heap, and those are the C++ library developers. And that was Leonard's question. So we come back to the code, and we can run this program. So this one would be under example 01 module 07 string. So we can go here and we can say run in terminal. And notice right here, so the size is 8. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, right? So we can ask it questions about the data that it holds. And there's more functionality, which at this time is really not like what we're after. We just want to understand that this guy is some kind of some kind of a special data type, right? So let's run this code to see what length is. Run in terminal. Right, so there's no difference. Any questions on the string? Usually we use size. Yes, Vince. And that's it, yeah. So behind the scenes, programmers use the char data type to create the string special object. So we can only use char with single quotes and for one character. Once we try to get cute, then when we compile this, it's going to complain to us. So we don't want to do that, right? So we've covered CIN, which is to capture data from the keyboard, and then the special data type, string. Every single time you want to use string, 100% of the time, you must include string, and you have to help the compiler deduce or find out where to find string, and it's always in the stud namespace. So we say using stud string. If we didn't have using stud string, then here we would have to say stud string, and it would know that, oh, it's in the standard library namespace. But usually this is the convention that's used in the industry. Yes. This one, no, it's usually better if we just put them here because it allows for better readability. Difference between length and size. Yeah, usually we use size, but I think they're the same. We can always go and look at the C++ documentation online, that CPP reference, or we can just do a search for size and length. But as far as I know, they're the same. Okay, so next topic. We talk about so we understand variables, we know what they are, we were introduced to them, we know we can do addition, subtraction, multiplication, and division with them, but we have to be careful with how we use them, right? So if we have two data types, integer and double, double's considered like a higher rank than integer. So if we use an integer and double and then we assign integer to a double, then that integer will be converted to a double. Obviously it won't have any decimal spaces, right? But it will be converted. Also, if we are using doubles and integers and then we're like, well, I want to assign this double. Double is a value with decimals, okay? And we're like, okay, I have an integer num and I have a variable decimal. I want to assign the value of decimal into the num, C++ will allow you to do that. However, you will lose the precision, meaning only the whole number part of the decimal will be assigned to the integer and you will lose the decimal precision. So that's important to understand, because if you're running your program and you don't know that, then you may get undesired results when you run your program. If you are using test cases, the test cases will alarm you right away that something's wrong, right? Because if you're using doubles and you're like, oh, if I multiply this times that, then I should get this. Once a test case fails and you see there's no decimals, that'll point you to an issue, right? But the issue is the data conversion between types. So let me see, I think I have an example for this. We come here. Examples, CMake list. Okay, I have 02 module available. Okay, and make sure that I also have it for my test cases. 02 module. Okay, so we jump to module 2 and we go to expressions, and let me see here, operator precedence. That's not what I'm looking for right now. I was talking about okay, let's do this one. So write int value return function, meaning a function returns integer. We name it convert double to int, accept a double parameter, so double some number. And that's our function prototype. Decimal at the end, okay? Not decimal, semicolon. Copy the prototype, go to casting.cpp, and then go here, open close curly brace. And what are we doing? Return the num parameter, okay? So this function, all it does is returns num. And I'm assuming what we want to show here is that we will lose the decimal precision. And we will test this with a unit test case. Any questions here on this piece? So we create the prototype in the header file. In the CPP, or the implementation file, we create the code. No semicolon. Please don't forget that, because if you forget it, then your program doesn't compile. Okay, so let's go to the test case. Okay, so test case convert to double to show that multiplying, and no, that's not it. Okay, this one, test case convert double to int to show that double converted to int truncates the decimal portion. So we create a test case, test double to int function, and we create the assertion with require. That if we call, you see, I think we have to include casting.h, right? So include casting.h. Okay, so now that function should be available to us. Double, convert double to int. Okay, and we can say 10.55 should equal to 10. If it's equal to 10, then we know that the decimal portion of a double is truncated when we convert from double to int. We go to CMake and we look for our test case. So we are in examples. We want to go to test, examples test 02. And that's a correct test case. Right click, run in terminal. is still building. Okay, so test case is passed, but we're always skeptical and we want to see details. So we can hit the up arrow one time, space -s, enter, and then we can see details. So notice that it did truncate the decimal portion. So 10 equals 10 and our test case passes. The other test case is just configuration, right? True equals true. So questions here? Okay, and just to get practice using CIN, we will go to the main program of this simple program and write some code to ask the user for a decimal number, and then we will call that function and display the return value. So we go to examples, 02 module, 02 casting, and we include the IOStream object. We know we will need cout, and we will need CIN. We create a double. We prompt the user for a number, right? So we say cout to display the screen, enter a decimal number. CIN, capture from keyboard, assign the keyboard value to num, and afterward we want to create a variable result, and we want to call the convert to double function, but to do that we need to make sure we include casting.h. So now double conversion is available to us, so we can say convert double to int, and we use the variable value num here. We capture the result in a local variable, and then we say cout int value is result. Any questions here on this program? I know there's during lab, could you run test cases on the cloud? Compiler, please. Yeah. Questions on this piece of code? Okay, no questions. So we can go ahead and run this program. So we go to CMake. We have to go find the executable. It's examples, 02 module, casting. It's this one. We can check. It is that one, right? Right click, run in terminal. It's asking us to enter a decimal value. So we can type whatever number, 55.99. And then we send 55.99 into the double to int, and notice that this function also eliminates the decimal portion, right? So when you do your homework, if you don't follow along with me, you can always go to my repository to look at the examples to see like what you need to do to complete your homework. Okay, so next topic. So operator precedence. So we go back to Explorer, and then we jump one up here to expressions, and we write some code. So it's asking us write prototype operator precedence with 3 parameters. Okay, so int operator precedence 1, int num1, int num2, int num3. So that's our function prototype. We go to expressions.cpp and we copy everything but the semicolon, open close curly brace, and it's asking us to return num1 plus num2 divided by num3. Okay, so return num1 plus num2 divided by num3. Any questions here? Hopefully, I don't know why it's showing this error, but we'll find out when we compile. Let me go to the test case now. So we go to test, module 2 test, and let me find the matching test case here. Okay. I think it's this one, right? So we create a test case. Test operator precedence 1, and require, we need to include expressions.h. You see it's not here, so we have to include it, otherwise we won't be able to use the function we just created. So expressions.h. so now we should be able to say operator. Did I name it that? Operator precedence. Copy. Oh, not that one. This one. Okay. Oh, so we're gonna run into problems here. Let's see here. Expressions 12, 6, 3. Expressions.h. Let me compile this because I don't know why it's snapping at me. So let me go here. Let me try to compile this one, see what we get. So build. Build okay. No errors. Let me go back to the test case. I'm pretty sure that one's going to fail. And usually it's because there's another file name expressions.cpp in my program. Well, let me confirm that it's going to fail. So let me go to run in terminal. I'm going to go through all of them. Let me see here. Oh, Justin, thank you. What was I thinking? That is part of the problem. Yeah, so it doesn't know what operator precedence 1 is. think here. Usually, let me see here, dot. Yeah, it's spelled correctly. Usually that's a problem with the include. So let me see here. I think I can navigate back to it. So this puts me here. This puts me in let me see. I think that's some trying to help it find the expressions that I want. So, but this should have gone away. So let's see. Let me double check this again. So I don't know what the issue is. Let me see here. Expressions right here. Include expressions, right? So see, even it gets me. Okay, so come back here, so then I don't need to go through all that mumble jumble I was going through. So I come back to the test case. It's still complaining, but let me cut this and let me try to build. I like it. Thought this should have fixed it, but it didn't. Let me try to execute this. Okay, so usually when this error occurs, that means that there's some other expressions .h in my program. So what I did is, since I'm here, I did // to come to this level, and then I went to // to come to the main level, and then I can access 02 module 01 expressions, and then at that time it allowed me to compile. But let's see if it lets us run. Yeah, so it's saying that it ran, but we want to do up arrow -s enter, and 12, 6, 3, right, equals 14. So what's the deal here? So 6 divided by 3 is 2, and 2 plus 12 is 14, right? So if we go back to our code here, so that all we're saying is that it follows math operator precedence rules. If we want to control, then we use parentheses, right? So this would net a different result. It would add num1 plus num2 and then divide by 3. So that's what I was trying to show there. And okay, so that's what I'm showing you here, right? So if we write that code, then we will get different results. Let me see if I have time. 6:26. Let me look at what we need to cover next. We have what, till 6:50, right? Yeah, we should be able to at least run this piece of code here. So let's go to expressions.h, and we copy this, and we'll name it operator precedence 2. And then we go to expressions.cpp. We'll copy this code here. I do caution that when you copy code, make sure you know 100% what you're doing, okay? Because then otherwise you can run into issues. So first, we have to change the name to operator precedence 2, and then we want to do this. Okay, so now we are ready for the test case. We can come back to Explorer, scroll down, find our test case, and test case operator precedence 2 returns 6. Okay, so we can write the test case. Operator precedence 2. We create one assertion, require operator precedence 2. Notice that now the IntelliSense knows what we're talking about. So if we say 12, 6, and 3, the result will be 6. 12 plus 6, 18, divided by 3, 6. So, and that's because we used parentheses, okay? So we go to CMake, right-click, run in terminal. And some assignments in the future, like you'll have to manipulate the parentheses to get the correct answer, right? So with Python and Java and C#, like they follow the same operator precedence rules, right? So, but I'm just demonstrating that this is indeed the case. Okay, let me see if there's question. No questions. Okay, so let's see what happens here. So everything's green, which we like. Up arrow space dash S, enter. We scroll up. So this is the one we're after, right? Operator precedence 2. So 12 plus 6, 18 divided by 3 equals 6, right? So now we have proof that using parentheses or not using parentheses can make a difference in what we get as far as results is concerned, right? So any questions here? Yes. Okay, here. Yeah, so since I'm the creator of the function, then I know what I can put in the test cases for a certain answer. Like for example here, I know that if I use these numbers, then it's going to do 6 divided by 3, 2 plus 12, 14. So I know the answers, and this one is num1, this one is num2, and this one is num3. And the same over here. This is num1, num2, and num3. num1, num2, num3. You can put whatever values you want to put here as long as you know how to derive the answer from those values. And that's how you create test cases. I think what you're saying is, okay, let me just finish this statement. So I think what you're saying is, how do we know what values to use here? You can use any values you want as long as you know how to use these values with your code to get an answer. Yep. No, in your program, that's what we'll do next. Like we'll use this one function. We'll use operator precedence 1 in a function, and it could be any numbers, but it's okay. I mean, I know we just tested one here, but any sequence of numbers will give us a correct answer because our function's correct, right? I mean, it's numbers. Another question? Yeah, and understandably so. It does look like extra work, mainly because these are easy functions. But if we have like a payroll function, where yeah, I mean we can go in main and create a program to test that function. But if our boss is like, well, here's 20 different use cases I want you to test. Yeah, you can test them in main. You can go and crank numbers in main, but you only do it one time. And then if your boss is like, oh, that's good, but can you test it again to make sure you're right? Then you have to go and do them again. And when you write the test cases, you program them one time. And if your boss wants you to run them again, then you just verify the numbers quickly that you formatted the test case and the required statements correctly. And then you hit enter and it'll run them a lot faster than a human can type. So that's where, and as your program grows and you surround your program with test cases, programs can have 100, 200, 300, 500, 1,000 test cases. And whenever somebody makes a change in the program, whether it's you or someone else, you run the test cases again, and all the test cases should pass. If an area of code you change messes up another area of code, your test cases will catch that, and then a different test case will fail, and that's the logic behind test cases. Like repeatability, maintainability, and then like it's like a protective harness around our program as our program grows. So yeah, I know for like one function it's kind of like really like you're making us do that, right? But just envision more functions, more test cases, and you can run them again and again and very fast. So that's where unit test framework comes in very handy. Yeah. Okay. Yeah, so again, the workflow is you write the header in the CPP code, and then you test your code. Once we test our code like we did here, now we can go to main and use it with confidence. This is very trivial. Like in main, we don't have any code, but usually when you merge your code with other programmers, or even in a program that you create yourself, you're merging code into existing code. So you want to make sure that that code works and you don't want to break it. So that's why test cases come in very handy. You see, like here, I know what you're saying. It's kind of like, really, like I just did it in the test case and you want me to do it again? But as we get into more complicated programs, hopefully you see the benefit in test cases. So here, like all we're gonna do is just C out, right? So using stat cout, and we have to include, let me make sure, Here I think it'll work because it just looks in our current directory first. I'll simply say, okay, int result equals operator precedence 1, 12, 6, 3, I think it was. And then we say cout result. You see, by now we're confident that operator precedence 1 is going to return the correct result because we've tested it. It's a very simple function. I mean, and you all are smart. You can be like, oh, duh, like it is going to return the result. But what I'm after is baby steps to teach you how to write .h.cpp, test it, and now use it in main. So we can run this program, which is cmake source examples 02 expressions, run in terminal. And then we scroll down, right? So 14, and if we go back and look at our test case, right? So if we used operator precedence 1 with 12, 6, and 3, it was 14. Logic behind this is by the time we use it in main, we're confident that we wrote the correct code and we can use it with confidence. Okay, so now we go to overflow and underflow. So there'll be times when let me go to Explorer, overflow, main. Here, like, I'll just create the main program. We're not going to go through .h and .cpp and anything like that. Mainly, I just want to show you if we have an integer, and remember the integers can only hold a certain number. What if we're at the largest number an integer can hold and we add 1 to it? What happens? So let's see what happens. So we come here and this is the largest number an integer can hold. So we'll say I want to display something on the screen, so IOStream. Yeah, it'll make it a negative, but more importantly, like, it'll yield incorrect results for our program, right? So okay, so we say, and then we're like, okay, num equals num plus 1, cout num. So what do? We assign integer to the largest integer the integer data type can hold. And then we are saying, okay, add 1 to it. And now we want to run this program. This program is overflow, 03 overflow. So we come here, right click, run in terminal. And yeah, it doesn't know how to handle the overflow, so then it just gives us like some weird value, right? So that's not what we're after. So we have to be very careful. Like, if you know you're going to be working with money, then you probably want to work with a data type long, which we don't cover in this class. But long can hold like very, very large numbers. And if long's not enough, then you can go with long, right? So now you know why I don't really get into those data types, because kind of like, really? Is there like long? No, there's only 2 longs, right? So that's an overflow. And one more example here. But let me think here. See if I don't use this a lot, so let me see if I remember the header. C limits, okay, C limits, and now we'll check for double decimal equals double min or min double. Let me see, I'm trying to, I think it was double min. Double Is it this one? I don't know if it's that one. Let me see. Yeah. And then if we're like decimal equals decimal divided by 10, let's create a new line character here. And then we say cout decimal. And let's see what happens. So this, what I'm trying, so this would be an overflow, meaning like it went more than the max for an int. And what I'm trying to create over here is an underflow less than the min precision for a double. So this is like max min, right? So from one extreme to the other. So run in terminal. So then we get like weird results, right? So we have to be very careful when we're using data types. I only use CIN in this class because the data that we work with is usually not that big, and we can use double because we know we're not going to try to do weird stuff with double. So you can find more information about overflow and underflow in, what's it, chapter 3 of the book, right? So, but these are just the examples of issues you can run into. Okay, constant. Oh, let me see if there's any questions first. No questions? Okay. So let's jump to constant. So constant is a read-only variable. And usually we use those for, like for example, if we're using sales tax or payroll tax, the value of pi. It's a value that we don't want others to modify while our program's running. So for example here, let's create a double return value function get area of circle double radius, and we copy everything but the semicolon. We jump from constants.h to constants.cpp, and okay, let's see what it's asking us to do here. Create const double pi with 3.14159. Okay, there's two ways we can do. First of all, let's not get in trouble, and let's make sure we include constants.h, and then we can say const double pi equals 3.14159. Okay. And now here we can say return radius times pi, right? If I try to get cute here and say, well, you're now 4, then it won't let me. It'll say that it must be a modifiable value, meaning this is a read-only variable. You cannot change it. The only way someone can change this variable is by stopping the program, changing the value here, recompiling the program, and redeploying, right? So it's a protection that we're giving to this pi value, because we don't want anyone to change it when the program's running. Square the radius first, okay? Radius times radius, okay, times pi, okay. I think, yeah, sorry, I don't use geometry in my line of work. I do a lot of addition and subtraction and multiplication, but not geometry stuff. So thank you, Nick. So questions here? I think in Python, go ahead. Yes. Yeah, we would have to include the math and use the square root function. Yeah. But we'll get to that. And then, just like in, so I'm not going to run this example. We're just, well, I showed you, what I wanted to show you here mainly is that we cannot change the values. It's protected, okay? If you want to run it on your own time, you can go ahead, but we have 3 minutes and I wanted to make sure I covered this last piece. So if we have a variable, num, just like in Python, we can say num plus equals some number, and it'll add 1 to the value. And one other thing we can do in C++, and this is very useful in loops, is we can use like num plus plus, so then it'll add 1 to whatever num is here. And we can also do num minus minus, so then it'll deduct 1 or subtract 1 from num. Shortcuts, right? So I think Python supports this convention. The last time I knew, which was like 4 years ago, Python didn't support this convention, like the unary operators to plus plus or minus minus. So you can do this, right? So if we want to display values to see what's going on, we can say include iostream using cout, and we can say cout num. Let's create a new line, and then we can add, and then we can subtract and display, right? And we can execute this program, which is 02 module 06 multi-assign. And we come here, run in terminal. So it was 10, we added num plus equals 1 to make it 11. And then we added 1 with num plus plus to make it 12. And then we said num minus minus and display to make it 11, right? So this one will come in handy in loops, in the for loop. This one's come in handy when you want to use shortcut for working with variables, right? And the plus equals can be minus equal, divide by equal, or multiply by equal. And they work the same. They're just shortcuts that make it easier for us. So it's 6:50. That's the end of the lecture for today. And I'll stay on. There's no assignment for today. We'll have a quiz at the beginning of class on Thursday, and a short lab assignment at 6:50 on Thursday. So if you don't have any questions, and that's the end of class, and you have questions, and I'm here to answer questions you may have.